Good morning. Welcome. I'm Brian Hokelman. I'm with Level 3. I'm the VP of our Cloud Ecosystem Development Team. Thanks for joining us today on optimizing your cloud architecture by looking at your network strategy. This is our third reInvent, and we've had a number of speaking engagements in the past, and we've really talked a lot about the Level 3 capabilities and the network services that we're providing to AWS and the enterprise customers connecting into that infrastructure. But today, we're going to get a little bit under the hood and talk about best practices that extend beyond the network service provider network and start to integrate into the LAN infrastructure, integrate into the data center, and some of the best practices around that. So a little bit about our agenda today. We're going to have a brief station identification so you know who Level 3 is and what our assets are. That'll be very brief. We'll talk a little bit about the trends we're observing with our customers in the hybrid and transformation space of cloud adoption. And then we're going to dig into some of these best practices. And we're going to talk about 3 or 4 main areas. So high performance connectivity, so distributed application environments and how we're preserving end user experience. We're going to talk about some of our SDN implementations around cloud and how we're delivering net new network services in terms of connectivity into those environments. Hybrid environments, how to maintain performance SLAs in distributed public and private domains. And finally, compliance and security. So how are you maintaining security? How are you maintaining compliance in these highly technical, highly distributed environments? And to help me with these conversations today, we have Michael Dews to my left. He's our product lead for Cloud Connect at Level 3. So manages and owns all of our different connectivity products into the cloud, as well as Jason McKay, who's a CTO of LogicWorks, and will be helping us with some of the compliance and security discussions today. So without further ado, we've got a pretty tight timeline here, so we'll kick it off and keep things moving. So Level 3, just in terms of who we are, we're a network service provider with a massive global reach. We're in over 60 countries. We own fiber infrastructure all around the globe. We're one of the most connected partners with our cloud service providers, so we're in every continent that they provide direct connect in. We support all of those locations. We also have a massive set of owned data centers and third-party data centers, and you can actually view those almost as direct connect POPs. So we provide connectivity services in those data centers so you can get a frictionless, easy connection into those cloud environments. And we're really looking at developing practices around next generation infrastructure. We'll talk a little bit about refactoring the network as you start to deploy into hybrid, into public cloud domains. How are you thinking about the network? How are you moving away from this concept of connecting my branch offices and my buildings to connecting my users into this infrastructure? And what are the things you have to keep in mind as you start to move down that path? Real quickly, just observations on what our customers are telling us and what we're seeing. So obviously, the cloud adoption is well underway. You're all here because of that. The implications, though, that we're seeing with our customers are very significant in terms of what are the implications to the people, the process, the network infrastructure, the data center fabrics that the customers are having to reanalyze and redetermine how they want to consolidate or expand those capabilities in their internal infrastructure. Security has long been the inhibitor of adoption and just debunking some of those perceptions. I think we saw today, if you were in Andy Jassy's kind of kickoff, all of the capabilities that AWS and the public clouds have around security infrastructure and what they're doing. Those assets are highly protected. They're spending over $1 billion a year on security practices inside public clouds, and now they're providing visibility and auditing trails and compliance trails for their customers. So the notion that the cloud isn't secure is just kind of falling away. We're also seeing a big move towards productivity and other types of services that customers are deploying into the cloud to make their constituents and their internal customers more productive. So it's not just about infrastructure anymore. So the likes of AWS workspaces and different collaboration platforms are being deployed and leveraged in a much more effective way. And then the globalization. So we're also seeing that the distribution of public cloud and the ability for customers to start to have mini clusters closer to either their users or their required infrastructure is grabbing hold. So a much broader global distribution of IT assets, putting them in close proximity to the actual either users or the services that we're trying to enable. And then big data with the likes of data lakes and machine learning, our customers are telling us that this is the real differentiator. The ability for them to outpace, outrun the competition is all around analytics and how they metabolize that and apply that in their businesses. And then lastly, software-defined networks, software-defined everything, right? So everything is becoming not just about the physical infrastructure, that's our business, but how do you start to have the usability be a software experience? So you're seeing that with GE talking today about how they're building their infrastructure, but they're building a middleware layer effectively to make it much more consumable by their internal customers. We're doing the same thing in the software-defined network space. We think cloud is actually where the use cases resonate. And software-defined networking is a little bit of a buzzword right now, but it's the usability. How are we going to change consumption models? How are we going to let customers actually use networks in a different way and have that on an on-use, pay-per-use type of model? So without further ado, we'll jump into some of the meat of the presentation today. I think the message that we're trying to talk about and have you come away from this session is the fact that the network strategy is pretty important. We all, the progression of cloud adoption seems to start in test dev and then with some greenfield application deployments. Then we get into some of the meatier production workloads and data center consolidation initiatives that are taking place. And the thing that we get trained on in the cloud is it's instantaneous. If I build an application on an EC2 instance, it doesn't work, I can just blow it up, start over, and move on. It's not actually like that in the network space. You have to be very thoughtful around how you're building network infrastructure that extends either LAN or data center environments across the WAN and into the public cloud. It all has to work together. And if you don't do it appropriately and you find yourself in a position that you have to rebuild it, it's oftentimes very painful. So we're going to talk a lot about today how you do that and how you do it effectively. Our observation is that it's a hybrid world out there. Our customers there's very few that are going all in right out of the gates. And so in this environment, obviously the network is tethering these things together. It's an integral part of the infrastructure. Proximity matters, right? And so our customers are trying to find ways to move their core IT assets they want to keep in a private environment closer to these public clouds, so they're within certain jitter and latency thresholds. And lastly, they're asking for SLAs. So our traditional notion of we deliver an SLA out to a DMARC and we don't care what really happens beyond that, those DMARCs those concepts are falling away. So customers are asking us to provide performance and visibility tools that extend beyond our network bookends into VPCs, into third-party gateways and the like, so that they can have a comprehensive view of the end-to-end solution. And so just so we get grounded before we jump in a little deeper, we are providing obviously a full set of network services. That's our business. But in this space, we provide a product called Cloud Connect, which is Level 3's private networking solution into our CSP ecosystem. And in this case, with AWS into Direct Connect. So we're providing that connectivity. And we do some different things. Obviously, you can buy that capability from a number of different providers out there, but we're doing some more thoughtful, tighter integration where we're deploying NNI infrastructure and we're allowing our customers to really self-select the profiles of network services that they want. So we provide a full complement of layer 1, 2, 3 connectivity options. We provide a very granular set of speeds and feeds. So we actually buy the 10 gig direct connect port and we absorb it into our service, and we make it part of a managed service. So when you order these things from level 3, you actually don't have to log on to the AWS console in certain instances. We do all that provisioning, we bake that into the service, and we manage that end to end. So just a little bit of orientation towards the services that we're doing and how we're innovating around that connectivity. The other thing is we view cloud networking selfishly at level 3 as a wedge strategy. So most companies have very diverse WAN, IPVPN infrastructure. It's purchased on multi-year contracts. It's tough to deploy, and it's hard to unplug and put another provider in there. We view this space as a cloud networking space as a place where level 3 can start to provide these services and start to provide a network platform that allows our customers and prospects to adopt our network services around data center and cloud connectivity in advance of or separate from any type of broader backbone IPVPN infrastructure, so they can live harmoniously together, and we can do things differently in our network space and cloud networking that doesn't really apply to broader IPVPN deployments. So we're gonna dig into a little bit of that today and talk about how we're providing network services in a net new environment. So first off, the first use case that we're going to dig into, and then I'll bring some of my partners up on stage here, talk a little bit about real-time data feeds. Obviously, proximity matters, latency jitter matters. When we have customers who are adopting different sensitive types of applications, we have to be thoughtful in terms of how we're actually deploying those services and how we're integrating them into our broader WAN infrastructure and connecting end users and eyeballs to those applications. And so a couple things, you know, in our world, in the IPVPN space, it's very easy for us to add additional sites. And in a meshed topology, we can add those endpoints very quickly and efficiently, and they just become additional nodes on our IPVPN. But inside of the customer's environment, inside of their VPC, we have to be a little more thoughtful around how we're doing these things. So if you look at a VPC, you actually, the IP address space is a /16. So that's the maximum amount of IP address space you have to have. It's also difficult to make those VPCs talk to each other if you're trying to have a high availability or a failover type of scenario. And so in those environments, you have to pre-plan how you're building that IP address space, how you're establishing the subnets, how that's talking to your LAN infrastructure, and how you're scaling out over time. So if you're designing that without enough runway and you're doing a collaboration type of solution where it's by the seat and like workspaces in AWS, there's the potential for you to run out of IP address space and not be able to scale the application, and that's what cloud's all about. It's about being able to scale rapidly. So in this instance, we're talking about for SaaS type of applications, for collaboration, how are you going to plan around the VPC deployment? How are you going to plan for that IP address space? How does it interact with the deployed IPVPN? And then if you're trying to set up talk paths between subnets and between availability zones, you have to think about that if you're going to have a HA type of environment for collaboration. So we're going to jump into some of the really exciting things that we've done at level 3 in terms of our SDN deployment and some of the implementations that we've done. And so again, our posture in the marketplace is SDN. Really, the use cases really resonate around cloud because you're trying to find ways to scale up, scale down. You're trying to find ways to have project-oriented workloads. We want you to have project-oriented network services as well. And so we're building out a set of capabilities that we're going to talk to you about, and we're also developing an API strategy that will allow our customers to, in the future, consume those APIs and bring up and tear down network connectivity between their data centers and their cloud environments or federated environments as they deploy into a multi-cloud solution. So without further ado, I'm going to ask Michael Dews to come up and talk about a couple of those use cases for us. Thank you.
Thanks, Brian. So first off, I want to thank you all for being here. I know we were competing with Werner, right, the CTO of AWS, so this is a pretty big turnout, so very much honored. Thank you much. So first up, wouldn't it be cool if the network connection was not your typical staunch, just flat rate, fixed bandwidth, or even worse, a usage model, which is more like a phone bill, right, where you guys get overages for unknown usage, and then you get a surprise end of month, right? Both of those scenarios are traditional telco. No one likes it. No one in the room likes it, right, I'm sure, right? It's not cloud related, it's not cloud aligned, and no one wants that, right? You really want the network, especially in the case Brian's talking about here, with the private connection, with high performance, to be really cloud aligned as far as the model, right? And so what we've implemented is a solution called dynamic capacity, and it gives you, the customer, the ability to control your bandwidth on the fly, very much aligned with your cloud model in a hybrid or an AWS Direct Connect model here, right? So we have three flavors of this. You can control it ad hoc. We have a self-service portal that you can control real time. In such cases, obviously, your workload's not known in advance. You can't schedule it. We don't want to do automatic. You want to basically control it manually for whatever reason. And you can do that via the portal. You can do it with Slider. We shall actually have a demo of this in our booth, and you can see it. We're about to release a app as well, a mobile app for this as well, so you can do a web-based portal or a mobile app, and it lets you control basically when you turn up and turn down a bandwidth as much as 300%. And it's not just usage-based, it's actually modifying the bandwidth real time. It also gives you advance notice of what your bill is going to be in advance. So you make an intelligent decision if you like this or not, and if you want to activate it, you let it rip, right? So it's true control. Now, other people want automatic type activation of this kind of feature, right? They want the bandwidth to dynamically basically expand up to 3x and then decrease itself back down either on a schedule or on automatic complete autopilot based on utilization. We offer those options as well. So you can control that also via the portal. You can set up a schedule in advance. If you know your workload is going to be a repeating type event every 2 weeks or once only, and it's going to go away, but you know it in advance, you can do an automatic schedule. The other option is do true automation, where you're doing it based on actual usage stats, right? It will monitor usage of your circuit, your EVC in this case, and you can set thresholds for when to bring it up or down, respectively, for actual thresholds. So true automation, right? But the key is you have full control of that, so it can directly align with your right scaling, whatever you're doing as far as workload migration for data or for compute. So hopefully you guys like that. You can go check it out at our booth if you like. Next up is an example use case of someone who actually uses this. So it's actually been running, like Brian said, this is in production now. We have it today with Amazon Direct Connect. You can opt for that now. We've had it for over a year, and you can use this now. Brock White is a construction company. They had a situation. They had regular backups they're doing weekly, and they were getting frustrated because their fixed traditional telco circuit was not cutting it, right? At that time, each week, they were having timeouts or delays or all kinds of failures of backup and movement of data. So they wanted to have something like this because they don't want to be monitoring this on a regular basis or trying to mess around with it. But they wanted the bandwidth not to be permanently at the higher rate because it's wasting bandwidth and wasting money, right? So they wanted to truly align with their use, and they have activated the schedule variant of this, and they schedule weekly backups, and they couldn't be more happy. As you can see from the quote in this slide, they're thrilled. Interestingly, if they chose the scheduled event. If you wanted to do it automatic, they could have done that too, but theirs was actually a repeatable event every week, right? It's a recurring event. So they chose the schedule, but obviously it could have been automated as well and done on usage if the event was not so repeatable, right? Same kind of thing. Anyway, reference architecture to implement this. This is, like Brian showed you architecture a minute ago of a layer 3 type connection. Now we're showing a layer 2 connection. And we have the alphabet soup here as far as our acronyms, so we're a telco, what can we say? But anyway, for you guys that aren't networking savvy and such, the CE is a customer edge router, and then we have PE is a provider edge between us and Amazon. On the right, you have the network-to-network interconnect called the NNI. It's a pre-existing 10 gig connection. It allows us to turn up circuits much faster. And in this scenario, you can do one of two flavors. You can use as shown here, the pre-existing NNI, and turn up circuits quickly. And then you can apply dynamic capacity on top of that. The EVC in the middle is an Ethernet virtual circuit, and it's basically your logical connection between your customer prim, your data center, and Amazon. It's a private connection, and you set the bandwidth as shown here at 200 meg, but you can triple that, up to triple, 2x or 3x that with dynamic capacity, and then accordingly you'll get the extra bandwidth, right? So We also have dedicated connections as well. So I don't want to make it imply here we only do hosted or shared connections across the NNI. If you want anything to a 10 gig connection, we also offer that. And we can apply that here as well. So you can do, the benefit for dedicated connections, by the way, is it gives you transparency. If you have a lot of VPC movement, you have a lot of dynamics in your VPCs and or VLANs, then a dedicated connection is often better because it allows you transparency of doing scale of VPCs, changing the VLANs around the fly. Whereas if you want control of bandwidth per VPC, the hosted connection is much better. That lets you do one VPC and one VLAN and one EVC each, and you can basically literally control the bandwidth per, if you wish. So we have both flavors. So changing gears here a little bit, hybrid cloud, right? You're probably going to get hybrid to death this week. But anyway, we'll talk about it here a little bit as well. I mean, we've already mentioned a little bit about this, but at a high level, right, your hybrid cloud environment, you're just basically dividing this into three basic parts, right? You have the public consumer, typically using the public internet, of course, on the left. You have Amazon Web Services, VPCs in the middle, and then they have legs in both camps, right? They have applications, either web or otherwise, that face the public internet for consumer access, and for some reason, be it regulatory, be it company policy, be it vertical, be it HIPAA or other kind of compliance requirements, they have a reason, and or maybe the migration, like Brian mentioned earlier, they're not ready to move, or they may never move all of their data and their workloads to the cloud. It may stay partly on-prem, permanently or temporarily. The bottom line is the right side of this diagram is private. Traditionally, people start off with this using a public internet connection on the right side too with IPsec VPN, right? And I think everybody in this room, or a lot of people in this room have seen this, and it works, but it's more complicated to set up. It has all the internet issues or congestion, other stuff, and max performance is limited there. And for a small dev and test environment, that's perfect. But once you get into a situation where you need higher performance, lower latency, more predictability, or your regulatory requirements dictate it, you may have to actually take that to a more private connection with better performance, right? Which is where Direct Connect comes in from Amazon, and where a solution like our Cloud Connect offers that, as shown in this diagram and talked about in this presentation. So at a high level, those are the building blocks basically for a hybrid deployment, and it could be for a variety of use cases, obviously, right? So architecture, again, is exactly as we showed a minute ago for dynamic capacity. You have the entire same elements here from a layer 2 perspective, everything from the customer edge on the left all the way to Amazon VPC on the right. Truly private the entire way. There's no public internet. It is typically private addressed IPs as far as RSC 1918 for you guys, so you can keep it completely in the domain and VLAN space the customer wants. You keep your private IPs, your VLAN tags, you control that for your VPCs, and it can play nicely in a BGP layer 3 sense between your customer router and your VPC, and you control all that, right? So you have the ability to really map it the way you want, and you get the control. And so obviously use cases for this include BCDR and a whole bunch of things that allow you to move data seamlessly and privately between your customer prim and your VPC, right? Question is, if you have additional security compliance requirements, then what do you do, right? So, talking about encrypted workloads here, what if the actual data at rest is not enough to be private, and even the private connection isn't enough? You actually have, for some reason, you have a regulatory or some other reason for your industry that requires you to actually transport data in motion encrypted and not just private, right? Can we do that? And the answer is yes. So we've partnered with some of our peers, including LogicWorks. Jason will talk in a minute here about how they add to this equation as well. First off, a little joke here. We're not selling a handbag as level 3. That's not a handbag there. And Cisco's not selling a Wi-Fi router either. So the logos are kind of funny, but anyway. We'll talk about the components here in a second. But anyway.
Just by a show of hands, how big of an issue is compliance, in your migration to the cloud? Are those things that you're having to deal with, okay. Just want to make sure that that's resonating with the audience.
Yeah, we see a lot more of that coming up more and more now, especially in financial and HIPAA and government. I mean, government, healthcare, and financial are the three biggies we see a lot of that going on in. And I believe a lot of you have that, which makes a lot of sense. So this bundle, if you will, or reference architecture combines what these four companies have come up with. We have the Cloud Connect we're talking about here in this session from level 3. We have, Cisco has some router and encryption and firewall combined products that both sit in AWS and your VPC, we'll show in a minute, and at your prim that can provide encryption and firewall policy integration between your prim and your VPC on top of us. We have F5 networks, obviously, who can provide you application delivery services, and then we have LogicalWorks who can help you in the overall best practices, for example, for a HIPAA compliance. And Jason will talk about that here in a second at length, right? So the actual architecture for this, if this will move, there you go. So take the former mentioned slides that have our architecture and now lay this on top of it, right? Now you have the traditional Cloud Connect and Amazon Direct Connect, but on top of that, you lay a couple of additional components, right? You have the F5 application delivery controller, you have the Cisco routers, you have an ASR or ISR at the prim, running DMVPN and encryption and firewall, if necessary for policy. You can also propagate policies up the line and be in sync with its CSR 1000V or CSR 1KV sitting as an instance in your VPC, right? And they have various flavors of that. It can go to from some 1 gigabit clear up to over multi-gigabit performance, which is very impressive, right? You can do multi-gig encryption in this case across this pipe as shown in red, and sit that in front of as an entry point into your VPC. And not only are you doing private connections, now you're encrypting the data in motion at multi-gigabit speeds. So we could give you like a 10 gig pipe, you can encrypt multi-gigabit across that natively, and there's no hardware involved on the Amazon side. It's all software from Cisco, it's all software from F5, and from us you have the typical Cloud Connect and Amazon Direct Connect. Very, very cool stuff. So if you're curious, we have representatives, will be representative here both in our individual booths and also, I think, in our booth later today and tomorrow. You can come by and talk about this if you like. And without further ado, I want to pass it to Jason to continue this discussion more about HIPAA compliance.
Thanks. Thanks, Michael. Good morning, everyone, and good to see you all here. I'm Jason McKay, I'm the CTO at LogicalWorks, and just a brief background on who we are and what it is that we do. We're a cloud automation and managed services company. It's based out of New York City. So our job is to help our clients, specifically clients with compliant or highly secure workloads, to deploy those on Amazon, scale them, and grow their business in a way that their teams are comfortable with and that we can demonstrate are secure and highly performant. So we'll talk a little bit about some high-level principles that we like to apply when we're looking at these scenarios, and I'll go into the weeds a bit about a sort of sample architecture. So network isolation is key. I'm sure you've seen the concept of public versus private subnets in a VPC. In our experience, the ratio of public to private is really typically like 1 to 5 across a deployment, simply because when you're exposing services out to the public internet, you really don't need that much in that public tier if you're dropping something in there like an ELB or an F5 appliance or some way to deliver that out to the internet. By default, everything should just be in a private subnet. There's no reason to expose things that you don't have to, and Amazon makes it very easy to do this. There's a lot of details we can get into about how the networking works in a VPC, and I think Amazon themselves have done some wonderful talks on that with the implicit router and such, but basically the freedom is there to isolate things as much as you want them to in the VPC and only expose those very small points that you want to. Internal ELBs are fantastic for inter-tier traffic in a multi-tier application in a VPC, and you can easily have your public or NAT or ELB or F5 tier at the front, underneath which are 4 tiers going from web to cache to database to whatever, all private on the private side. In a topology sense, we like to do a hub and spoke model in our deployments. Run multiple VPCs. Don't cram everything into a VPC. There's no reason to do that. Especially that nowadays we have the capabilities of peering in between VPCs. This is a wonderful thing and allows us to create things like shared service buses in one VPC and production workloads in another, stage, test, dev, separate all your SDLC environments into their own VPCs. This makes a lot of sense. And also lets you really tighten down the security on the production workloads, right? You want to really minimize the number of people that log into that environment, the number of hands that touch that. And in another very important note that I'm going to come back to several times, you want to use automation where possible to allow all of that work that gets done in production to be done in a repeatable, human error-free manner. So that's a key point. We also have the flexibility of using multiple accounts. This is something that comes into play for a couple of reasons. If we have multi-tenant environments, it may make sense for one of the business units or end clients or whatever to have their own VPC. that's peered back to whatever that common shared service bus is for the sort of parent company or group. And the networking allows you to do that between accounts, peering across VPCs between accounts without a problem. There's no hindrance there, so it makes a lot of sense where appropriate to do that. I think Brian referenced earlier the security concerns are sort of falling away around the cloud, and we're seeing a lot of new features. We just saw some this morning that are speaking to that. So the introduction of CloudTrail and Config over the last year and a half for us have been a huge boon, since we're essentially in co-managed environments with our clients. The ability to show who did what down to a named engineer level is fantastic, right? But you have to turn those things on, and they're not on by default, right? So one of the things that we've done for our clients is set up automated scanning, and we'll basically run through our entire client list on a daily basis, and if we see that some client deployed a single resource, a T2 micro in Singapore, we're gonna go configure, turn on, and enable CloudTrail and Config for that environment immediately. And if somebody were to come along and for some reason, either nefarious or mistakenly turn that off, we're just gonna turn it back on automatically, because we can't have a situation where auditing is not turned on, right? That's an absolutely key thing. And then another thing, just a sort of design principle, another thing Brian referenced earlier is give some thought to your network layout and your network planning, even in a VPC. The ability to spin these things out so quickly, it's so freeing, and people go a little bit crazy. And I've often seen deployments where there's, 5, 6, 8 VPCs all peered together, and all of a sudden they realize that, whoever deployed them did so with, 10.0.0.0/16 for each, and now you're gonna have a bad time, right? On the other hand, once you're within a VPC, if you've appropriately designated a supernet for it that makes sense for what your expected growth there is, feel free to isolate out those subnets and tiers of the application as you see fit. Obviously, you lose some IP space as you do that, but the freedom that gives you is very good in terms of adjustability going forward. Route tables and associating them, this is one of the things that we learned early on. Don't use the main route table. I'm pretty sure nobody does that anymore. But when you deploy your subnets, associate a route table with your subnet. It's gonna give you a lot of freedom. That's gonna give you the ability to take that particular subnet and only allow its traffic over a peering group to a different VPC, as opposed to, say, you're using a single route table for all the subnets in a certain tier of the application. Sometimes that makes sense, but route tables don't cost anything. So the only cost there is, as I mentioned, potential complexity, but there's a big way to get around that complexity too. Don't do any of this by hand, or do it by hand once, right? And then get it into a templating system, get it into CloudFormation. If you're not doing this today, stop, just do it. Go labor through some JSON and do it, because once you put that work in, the ability to reproduce that and make minor adjustments without having to keep all of these moving parts in your head, how many route tables do I have, what's associated with what's going over this peering link, it's all documented, right? And so when you're changing your environment by updating CloudFormation stacks, it becomes self-documenting, and you can actually see what you've got going on. You can minimize the human error mistakes. So we'll look quickly at a fairly simplified topology here, in which we've got a sort of management hub, which is essentially a shared services environment, with a peering connection to an actual production workload environment, and with a direct connect and connectivity back into an on-prem, right? In this case, we're doing management traffic from on-prem into the central hub, and that's where we may have things like Bastion hosts, we may have centralized authentication there, we may have additional centralized logging there, and that's where we're going to be putting things like security appliances or whatever it is that we're doing as far as log aggregation or IDS. IDS, by the way, is another one that when you're thinking about, for those of you who are in the early planning stages about moving into a hybrid scenario, the tooling that you use on-prem is not necessarily going to be the same tooling that you use in the cloud, just by virtue of the platform being what it is. We're all pretty familiar with IDS systems that work using port mirroring. Just slam all the traffic into that port, the appliance slurps it up, there you go. There's no port mirroring in Amazon, sorry. It would be great, but there isn't today. So you're gonna have to use a system that uses some kind of agent-based way of collecting that data and putting it back to an appliance for analysis. You can see in this case that we've got multiple private subnets, not quite the 1-to-4 ratio I mentioned, and a single public. And there's really nothing there except NAT right now, right? Because we don't need that, except if we're offering a public service, we can do ELB or an F5 or another traffic management system. And then we've got our application tier, which is now completely isolated. It can talk to, via security groups, it can talk to the upper tier, and it can talk to the database tier in the back end. But it doesn't have to be exposed to the public internet at all. And if it needs to go out there for any reason, it can do so through a NAT gateway. You'll notice that I put multiple NAT gateways, one per availability zone. That's a design decision that you can weigh yourself, the pros and cons. A lot of people slap a single NAT instance in there, which means that if you have a problem with that one, none of your instances, no matter what AZ they're in, can hit the internet. This at least gives you the ability to, you're not at the mercy of a single instance, right? So if you lose your NAT for some reason, for some period of time, there's maintenance on it or whatever, at least 2/3 of your architecture is able to get out, right? There's other ways you can solve that too. You can go a lot more complex there, but as far as a basic rollout, that's a good way to approach it. And as you can see, obviously we're going across multiple AZs. This is not optional anymore, although you'd be surprised at how many companies I see with otherwise relatively mature deployments running in a single AZ. And I mentioned a little bit about the importance of automation, and this is everywhere for us, not just in the templatizing your environment, enforcing the turning on of logging and config, but also configuration management. If you're not doing this, start also. We really want to get away from humans going in and making config changes. I think we're all well aware of that now. On the left-hand side, you can see a snippet of a bucket policy that we're using to enforce server-side encryption on an S3 bucket. We don't want to allow anybody to write to that bucket unless they're doing so with server-side encryption turned on. And that's relatively straightforward to do. There's a lot you can do with bucket policies and IAM in general in terms of very granular privilege control, and it's absolutely key. And then encrypted EBS volumes are also useful for us, particularly for HIPAA environments. If you're comfortable with Amazon having the keys, that's a very straightforward way to do it. You can also use KMS, which is Key Management Service, if you want to have a tighter control over that. So with that, I think that's a good overview. I hope that was helpful to people about some of the stuff that we're doing for security and compliance-focused environments. And with that, I will turn it back to Brian.
Thank you. So just a little bit about our involvement in reInvent this year. We do power the entire test drive lab with Direct Connect provided by Level 3. We're also doing the advanced networking breakout sessions where we're setting up some lab environments for you to get hands-on experience and exposure to setting up some of these configurations. And then we're also down in the exhibit hall as well. So lots of places to find out more and to come engage in terms of how we're setting up network connectivity for our customers and into AWS.